Factoring polynomials, part one, the PQ and AC method. I want to understand the basis of polynomial identification. And when we talk about polynomials, we're usually looking at trinomials. This is the most common form of polynomial equations, where we get the quadratic functions, and basically we get the parabola. Right here is one of our, a common polynomial, x squared plus 5x plus 12. And as I said, when we look at quadratics, there are three components. There is the first component, which is to the second degree, the x squared, y squared, t squared, where there's something that's squared. That is the ax squared. Then there is the middle component, which is a single variable, such as the x. So I have 2x squared plus x. The b is the coefficient in front of it, and then our c is our constant. So when we talk about a quadratic formula, it's in the form of ax squared plus bx plus c, where the a, b, and c are actual numbers that go in front of it. Here are three right here. Y equals 6x squared plus 12x is 25. My a is 6, my b is 12, my c is 25. T equals 13z squared, my a is 13 right here, and b is negative 22, c, and then my c is 71. And then I got f of x equals x squared plus 6x plus 15. This a right here is just 1. We don't put anything there, so it's 1. But that is, a is 1. B is 6, as shown right here, and C is 15. We use quadratic equations in quite a bit of our everyday life in terms of business, science, so the social sciences. We can determine to maximize the area. If we know what our if we know one side is x and our side is x, and what the area is, we can know how large to make something. We're talking about varying areas. Also, we can determine where to maximize revenue. When this is right here, where the demand and supply is in economics, and then where the maximum profit is as well at this peak. Now I want to teach you the PQ method. The PQ method is where we recognize something, a quadratic equation, standard form, ax squared plus bx plus c. We want to break this up into two binomials. That we want to factor it, ax squared plus bx plus c, because then I can determine a lot where it starts, where it ends, the high point, the low point, the vertexes, and all formulas can basically be made into two binomials when I have a quadratic. And if we use FOIL, remember FOIL means first, outside, inside limits. Here's my first, x times x. My outside is x times p. My inside is p times x. And then my last is my p times q. And we are going to look at that p and q, and actually the coefficients in front of it, to help solve solutions. Remember, my p times q is going to be my c. My bx is going to be my px plus my qx. So if we can find out the component for whatever p plus q is in relation to p times q, we can factor this out. Now, this only works where the a equals to 1, like x squared plus 6x plus 9, x squared plus 5x plus 12. I can't do 2x squared plus 10x plus 15, or 3x squared plus 7x plus 10. It's got to be a single x squared. I'll show you another way to do that in a few minutes here, though. Here's one right here. You can use the PQ. Y equals x squared plus 9x plus 8. It's just a 1x squared. So we're just going to know it as x squared. And what I'm going to do is, remember, I said my p times q is always going to be equal to 8. So I'm going to figure out what number gives me 8 when I multiply P and Q together with two numbers? And then the P plus Q is going to equal 9. So first I'm going to do all the factors of 8 that give me 8. 1 times 8 is 8. 2 times 4 is 8. Negative 1 times negative 8 is 8. And negative 2 times negative 4 is 8. And I've got all those. Now I'm going to add up my P and my Q. I'm going to see which one gives me 9. 1 plus 8 is 9. This is it right here. So when I look at this, I have to just determine how to factor. I don't need to go any farther. The other ones don't add up to 9. 2 plus, I can look at this. 2 plus 4 is 6, so that's not it. Negative 1 plus negative is negative 9. Negative 2 plus negative 4 is negative 6. So that's why I know it's this one. But now I know my P and Q are 1 and 8. So when I factor, my Y equals x plus 1, got up there, and x plus 8. X, let me put my x there first, x plus 8, which I've actually written much more neatly right here. And here's the thing. If I can determine where my equation starts and finishes by looking at if it starts at where x, right, where y equals 0, remember, I look at my line, my graph here, y is equal to 0 here, that's going plus y, that's going minus y. And wherever y equals 0, I can see what my x is, and y equals 0 is where it starts or where it finishes. So if I put in negative, let's see, I got negative 8 here. If I put in negative 8 for x, that's negative 8 plus 8, and negative 8 plus 1, that gives me negative 7, and negative 8 plus 8 is 0. I multiply those two together because they're both in brackets. That equals 0, which makes perfect sense because at 8 is at 0. 8 is 0 right here. I can do the same thing with negative 1. If I put in negative 1 for x, negative 1 plus 1 is 0. Negative 1 plus 8 is 7. 7 times 0 is 0, which gives me my other 0 right here, which I've done right here. We can use PQ method on this one. Y equals 7, y equals x squared plus 7x plus 12. My P plus Q is 7. I'll put that right there. My P times Q is 12. So let's figure out all the factors that give me 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Negative 1 times negative 12 is 12. Negative 2 times 6 is negative plus 12. Negative 3 times negative 4 is 12. I'm going to add all those up now. 1 plus 12 is 13. Well, that's not 7. 2 plus 6 is 8. That's not 7. 3 plus 4 is 7. I'm going to stop right there. I showed you all of them, but we only go as far as we stop. So basically, my factors are when I factor out x squared plus 7x plus 12, the x plus 3, x plus 4. So that is basically, if I put a negative 4 and negative 3 right there, you can see that is my 0 points where y was 0. And we have factored. Now, what if a, the component in front of the squared, is not 1? A squared plus bx plus c, and where a is equal to 2, 3, 4, 10, something, but it's not 1. We can use the AC method. Now, refresh your memory again. The a is in front of the x squared, the b is in front of the x, and the c is the constant. And I've got a component here, an equation, y equals 3x squared minus 10x minus 8. I'm going to use the AC method. Starts out very similar to the PQ method. I'm going to take my A and my C. I'll multiply them together. That's the AC. 3 times negative 8 is negative 24. And like I did before in the PQ method, I'm going to find all the factors that give me negative 24. Negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6, negative 6 times 4, negative 8 times 3, negative 12 times 2, negative 24 times 1. Now what I'm going to do is I'm going to figure out which one of these adds up to the b, the negative 10. And I go through all these. Negative 1 plus 24 is 23. Negative 2 plus 12 is 10. I circle which one it is. Negative 12 plus 2 is negative 10. But we're not done yet. But we're going to recognize this negative 2 and 12. Because what we're going to do now is we're going to substitute. My original equation is 3x squared minus 10x minus 8. I'm going to replace minus 10x with minus 12x plus 2x, which I got from right here. So it's the same, it equals the same thing. Negative 12x plus 2x is the same as negative 10x. But you're going to see where I'm going to go with this. I've replaced negative 10x with 12x plus 2x. And then what I'm going to do, I'm going to drop this equation down. I'm going to parentheses in front of the first two parts. Negative 3x squared, 3x squared minus 12x plus parentheses in the second two parts, 2x minus 8. And I'm going to see if I can factor out of that this first binomial. I can pull out a 3x out of this. 3x times x is 3x squared, right here. And then 3x goes negative 12x minus 4 times. So I've factored this out, 3x times x minus 4. And then 2x minus 8, I pull a 2 out. I can pull a 2 out of that. And I left x minus 4. And notice I got an x minus 4 in both of these. Now, if I put x, I can factor out x minus 4. I'm left with x minus 4 and 3x plus 2. That is my factored equation. As I can prove it to you here, when I graph that, it will basically y equals 0 at negative 2/3, 0, and 4, 0. Both give me 0 at the y. But all I did is I just replaced the negative 10x with 12x plus 2x, separated them out right here, and then factored whatever out. I got an x minus 4 in both of them. So one more here. Y equals 5x squared plus 7x plus 6. Use the AC method. A times C is 5 times 6, which is 30. And my B is that equal to 17. And down here, I put all the factors that give me 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. And the negative versions of those. Now I'm going to add those up. 1 plus 30 is 31, so that's not it. But my second one here, and obviously because I circled it, 2 times 15 is 30, 2 plus 15 is 17. So I'm going to rewrite my equation. Instead of 5x squared plus 17x plus 6, I'm going to replace 17x with 5x plus 2x. And I can do 2x plus 5x. Doesn't really matter. It'll work out either way. So I've replaced 17x with 15x plus 2x. And now I'm going to separate the first two from the last two. And 5x squared plus 15x, I pull a 5x out of that. That leaves me x plus 3. I can pull 2 out of this one, 2x plus 6. That leaves me x plus 3. And look, I've got x plus 3 in both of these. So when I finally factor this out, this is going to be equal to 5x plus 2 times x plus 3. And I graph that, this is what I get.